Okay. Relation is association in between two sets. For example, let me put an example to understand more clear. Relation. Suppose que we have one set. Que set is the collection of the object que I call capital X, que represent, for example, the students. The students in MAC1106 class. Entonces, hypothetical, to make sure the example, I copy 4 names. For example, Sally, this is another semester. Paul, Kim, and Luis. 4 students, only 4 students. And we have another set, Y, okay, the overall represent the overall grade and this subject, okay, it's possible to get A, B, C, T, or F. Okay, this is the letter case available to the grade, no, in Miami-Dade College, no. And the relation is the association. Relation is the association. For example, hypothetically, you know, the first student, Sally, get A. So you represent like an ordered pair, X, Y. Entonces, Sally, A. This is the grade associated with the Sally. Paul, get B. King, get B also. Luis, parenthesis, Luis, get A. Okay, so the relation is the collection of the different ordered pairs. Okay, one ordered pair. It's super important, extremely important, the order. For example, this is the domain because it's the first set. And this is the range because it's the second set. So first component, domain. Second component, range. And the relation is represented by ordered pair. This is one way to see that. It's obvious that there are many ways to represent and visualize relations. Well, using formulas, using graph, using this set. But actually, we have two components because relation is the association between two sets. Okay? This is a relation. Everything is clear? Now function. Function is more interesting. Function, let me copy the definition of the functions. And after we analyze, because the definition is a little bit confusing, at least for me. It's a relation. Function is a relation. Pero special relation. Such that each value or each item, each element in the domain is associated with, and this is the most important part of the definition, only one value in the range. Okay, it's illegal too, only one. Okay, so the definition is a little bit confusing. To clarify this definition, I propose you another example. Suppose no people anymore, no students. Suppose X is a number, 1, 2, 3, 4. This is one set. This is domain. And Y is ABCD. This is just element inside the set. This is set to set range. I create different relation and we investigate if this relation is a function or not. According to the definition, Mr. Lizzie. Wow, Lizzie. Next time that you are doing this, you go out, Lizzie, okay? Okay, now here, let me see. Grid view. Okay. Now, let's see relation. Relation number one. To understand function. It's a relation. You say that function is a relation. But suppose this function, this relation, sorry. 1, A. So you associate 1 and A. You associate 2 and B. You associate 3 and C. And you associate 4 and D. So my question is, this relation is a function or no, according to the definition? According to the definition, it's a relation such that each value in the domain, que es 1, 2, 3, 4, is associated with the only one. Yes, of course, yes. The answer is yes, because it is one-to-one function, no? So 1 is associated with the A, and so on. 2 is associated with the B, 3 is associated with the C. Okay, super. This is, and 4 is associated with the D. It's a one-to-one. One-to-one relation que es obvio que satisfy the condition for the function. Yes, it is. Yes, a function. Yes, function. Suppose another example. Que clarify much better the idea for the. Suppose 1, A again. Suppose 2, B again. Suppose 3, B. And suppose 4, A. Okay, it's another arrangement I create here. I want to analyze it as a function or not. Let me see. Okay, to understand this, I create this representation of 1 is associated with the A, 2 is associated with the B, 3 is associated with the B again, and 4 is associated with the A. Like that. Okay. What do you think? It's a function or not? Okay, the most important, the confusing part in the definition is allow one value in the range. So it's like a many to one relation. But the most important in the definition is this part, 1. See, it's 1 here is a function. Okay, do you see or no? So the answer is yes, comma, it is a function. So what is the violation of the function? Well, I bring another example. Relation 3. Relation 3 is relation 3. Suppose relation 3. Relation 3 is 1, A again. 2, B again. 2, C. And 3, D. Okay, entonces the representation is 1 is associated with the 1A, 2 is associated with the B, and 2 is associated with the C. This is the illegal idea, because this is, and 3 is associated with the D. This is okay, but this is a central idea. Look here. This is one too many. And when it's many in the range here, this is a violation of the definition, no good. And one too many is obvious que is no function. So no, it is no function. Okay, in conclusion, when you analyze functions, or when you analyze the possibility of the function in the relation, you keep in mind that one-to-one is okay. One-to-one is okay. And many-to-one is also okay. And why is okay? Because it's one here. Look, only one in the range. I don't care what happened in the domain. And one too many? No, okay. It's not okay. Okay? Do you understand very well this or no? Do you understand very well definition for the relation and definition of the function? We practice, of course. Yes, okay, good, very good. May I erase the board or no?
Yes.
Yes.
Okay, go ahead. For example, I bring several examples. Okay, the first example, example one. Okay, example one. One set is relation one is 2,3, 4,1, 3, -2, 2, -1. What do you think? Is a function this relation or no? And what is the reason que yes or what is the reason que no? So it's, justify the answer, no? Si it's yes or no. What do you think? It's a function or no?
No.
No, why no?
Because it's one too many.
It's one too many. What is the problem? The problem I suppose que es 2, right? 2 is associated with the 3, and also 2 is associated with the negative 1. This is the problem. Okay. And by the way, what is the domain? Domain. Domain is always, keep in mind this word, important word. Domain is the set of the first component, que es x, comma y. The domain is 2, 4, 3. And not necessarily repeat when the 2 because it's the same element. This is the domain. And the range is the value of the second component, okay, 3. Doesn't matter the order. The order is not important. 3, 1, -2, -1. This is clear. Let's see another example. Suppose this relation 2 is 2,3, 4,3, 3,3, and 5, -1. My question is a function or no? Yes or no? And reason.
Yes.
Yeah, you are right.
Yes.
You are right, because 2 is associated with the 3, 4 is associated with the 3, 3 is associated with the 3, and 5 is associated with the negative 1. This is classical many-to-one. And the most important in the definition is that part, 1. It's only 1. Good. And one more time, define domain and range. What is the domain? What is the domain? Help me.
2, 4, 3, 5.
Domain, you say is 2, 4, 3, and 5. Yes, you're right. And what about range?
3 and -1.
Super. Very good. 3 and -1. Remember, the most important property of the set is no repetition is necessary. And also the order is not important. Suppose que another student answer like that. 4, 3, 5, 2. It's the same. This and this set is the same. It's equivalent set. Okay? Okay, guys, super. Now, I can erase the board.
Yes.
Okay, another fantastic way to determine if one relation is a function is using graphic. For example, let's do in several graph. This graph, this graph, this graph, this graph, 4 graph. This is x-axis. This is the y-axis. Y-axis. And suppose one graph like that. One graph like that. This arrow indicate that this graph continue forever in this direction. One graph like that, and one graph can look like a circle. It's a closed figure. Entonces, to determine si this graphic corresponde with the function or no, you apply one thing que es called vertical line test. Vertical line test. And this is easy because you are doing vertical line. Vertical line. Vertical is 90 degrees. And the arbitrary position at the graph. Look here. See this vertical line test crossing only one point. Es obvio que es a function. Yes. It is a function because passing the vertical line test. Not necessarily in this position, you are doing in different positions, but only crossing only one point. This likewise happen. It's a function, yes. This no, crossing 2 points. And this of course no, crossing 2 points. 2 or 3 or more points. Only 1 point is a function. This is the idea of the vertical line test. Why? It's the same thing we studied before. Suppose we have one value of the x here, and this is associated with the 2 values of the y. This is y1 and this is y2. So the situation is que x is associated with the 2 values of the y que do not satisfy the definition of the function, no? Because it's one too many. Clear? Clear? So sometimes we have a set the Caesar. Graph is also easy, but you apply a different technique. You apply the vertical line test, and that's it. Vertical line test. Okay. Do you follow me?
Yes.
Nice. Okay. Another possibility to determine if one relation is a function or no is when you have the formula or you have the equation. You have the equation. But be careful because equation is a little bit more complicated because, look, let me show you. Equation, so identify the function by the equation. Now you need to identify no graphic. Suppose that you have no the graph. Identify the function by the equation. But the problem, what is? The problem is that we have different possibility to write the equation. Look, so let me explain one important idea. Okay, so for example, you have different way to write the equation. The one possibility is the implicit form. Another possibility is the explicit. What means implicit and explicit? Well, it's easy to understand because implicit is, well, when you write the equation like that, 3x plus y equal 5, for example, in which you do not isolate any variable. It's mixing together here. However, explicit is more clear, and this is super important when you need to analyze, you need to identify, see, this equation corresponds with the function. Oh no, you need to write an explicit. And explicit is always when you solve for y. So you put y alone, isolate the y, is equal minus 3x plus 5. Do you understand the difference between implicit and explicit? Okay. Another example to illustrate the idea. X squared minus y equals 6. If you want to write an explicit, you solve for y, you put a y alone. Maybe you put x squared, well, you put x squared minus 6. So you put x squared. Look, the manipulation is x squared minus 6, and you put a y on the right hand side. And you interchange. Okay? This is explicit when the y is totally isolated. One more example, and that's it. X times y equal 4, and y is equal 4 divided by x. Okay, isolate the x as explicit. And explicit is synonymous to be clear, And implicit, no. Implicit is confused. So in order to identify, see, one equation corresponds with the function. Oh no, the first thing you should do is write the equation in explicit form. Let's do a couple of the examples to illustrate this idea. Look, suppose example 1. Example 1 of that part. Suppose that we have y is equal to x squared. Wow, it's easy. It's easy. Because it's expressed in explicit form, because y is isolated. I can see clear using my eyes that one value of the x corresponds only one value of the y. Suppose, I don't know, hypothetically, x is equal 3. So y is equal 3 squared, que es 9. Only one. So it's a function. It's obvious, right? By the way, curiosity. So you put in the calculator or you put in the decimal to see the graphic of this, it's a parabola. And when you apply the famous vertical line test, pass the test, crossing only one point. Okay, this is example 1. It was clear, explicit, and it's obvious that it is a function. However, in example 2, something weird happened. Suppose que es x equal y squared. This is not explicit. This is explicit because y is isolated. Explicit. This is not explicit. This is implicit because y is not isolated. So the first thing you should do is write n explicit. You transform this to explicit. Y alone. To do transformation, you apply square root both sides. So square root here and square root here. It's obvious square root and second power cancel out each other. It's y alone. Entonces es equal to square root x. Pero don't forget plus and minus. I guarantee you 100% that this original implicit equation is equivalent 100% with this explicit equation. Okay, but what's going on? What's happened now? Well, I can see that one value of the x have two values of the y, y1 and y2. Who is y1? One of the positive guy, square root x. Who is y2? Negative square root x. So says one too many is no function. No. Okay, maybe there are more complicated examples, no, but it's not important. This is not the big deal. Do you understand this or not? It's easy, eh? answer it, guys. It's okay? We are doing okay?
Yep.
Okay. May I erase?
Yes.
Mm-hmm. Okay. Well, now let's move on to the. It's a continuation, but it's another topic. It's a function notation. Function notation. Okay. It's very important tools in algebra that we use in everyday function notation. The function notation is, for example, you have a name of the function, name of the function. Okay, normally in algebra, the name of the function we using only one letter, F, G, H, or two letter or three letter, for example, LM, LOG, sign. Okay, this is different name for the function. Basically, in mathematics, the convention is 1, 2, or 3 letters, no 4, no Maria, no. Entonces now, the function notation is you put f of x, you put the parentheses, and you put x, okay, this is a symbolic way to indicate the element and the domain. And these parentheses do not indicate multiplication. No. It's a symbolic way to indicate. For example, you assign f of x is equal x plus 6 divided by 2x plus 3. Okay, and this is, this is synonym or another way to call y. So some people prefer call like that. Y is equal x plus 6 to x plus 3 because I know very well that y and f of x is the same. But this opens a new possibility. This opens a new possibility to manipulation in algebra. So this is possible. It's okay, but this is better, in my opinion. Let me explain why. Well, first of all, we can evaluate in one specific number. For example, f evaluating 2. Okay, what should I do? Plug it in. 2 plus 6 over 2 times 2 plus 3. You apply the order of operation, and the top is 8, and the bottom is 2 times 2 is 4, plus 3 is 7, 8 over 7. Okay, this is super easy. Just plug it in and that's it. But we can do several transformations. You can do, for example, reflections. We can do translation, so, shift and horizontal, vertical shift. I promise in next class we study in detail transformation. But this is the anticipation for this idea. For example, not only number, no. We use it, for example, reflection. What is the reflection? Reflection is you change x for negative x. The interpretation of this transformation is reflection. So when you change x for negative x, we are doing reflection. I don't want to explain in detail in what direction is the reflection, but it's reflection. So you replace x for negative x plus 6 divided by 2 times negative x plus 3. And leave it like that? No, it's so ugly. 6 minus x is much better. You put a positive in the first. And this is minus 2x plus 3. Or you write like that, 6 minus x over 3 minus 2x. And this is the reflection of this original. Okay? Reflection, well, in this case, reflection about y-axis. But I explain detail next time. But we have another kind of reflection. We have reflection about the x-axis. Case different is you put a negative in the front. This is another reflection, but about the x-axis. This is easy because you put a negative in the front and you copy exactly the same f of x, like the original. And that's it. This new expression is the reflection about the x-axis. And that's it. No, we can do, for example, translation, maybe horizontal or vertical translation. Well, horizontal, let me try horizontal. Suppose F evaluate in X plus 2. This is a combination variable and number. Okay, it's easy, it's super easy, because the only thing you should do is replace in the original X, replace by X plus 2. Entonces, X plus 2 plus 6 over 2 times X plus 2 plus 3. Okay, entonces X plus 8, because 6 plus 2 is 8, you apply this trinity here to X plus 4 plus 3, X plus 8 divided by 2X plus 7. And this expression represents like a translation, like a shift. In what direction? Well, I don't know exactly what direction. I explain in detail next lecture the transformation. We dedicate one entire lecture to the transformation. Get very, very complicated. But okay, the possibility, so the potential of the function notation is we can do transformation after, this is not important now, the interpretation of this. Interpretation is next time. Another possibility, open the door, and the function notation is to find, for example, the famous point, is the y in a set, and x in a set. Some student asked me, Professor, what is the formula for finding any time y in a set and x in a set? I need to remember the mnemonic divide. What is the formula? Okay, the formula is, look, suppose you have one function, f of x, equal absolute value x plus a. Here I want to find y in a set and x in a set. Well, I need to remember only for finding the y in a set, you evaluate in 0. Because this is the point in which the curve, the function, crosses the y-axis. In the y-axis, any point on the y-axis, the first component is 0. Entonces, evaluate en 0, 0 plus a. 0 plus a is a, actual value a is a. Wow, entonces now the point is the famous point 0, a. Okay, y in a set. This is another application of the function notation that we are using every day, guys, every day. When we study more complicated problems, you know, this is the formula for finding y in a set. Now, what is the formula for the x in a set? Well, it's similar. It's the function equal to 0. Okay, in our specific example, the function is absolute value x plus a equals 0. In this moment, we have equation that contain absolute value exactly the same we studied last class. But when it's 0, you know, we have only one solution. Only one solution. Therefore, you remove the absolute value, in this case, not two solutions, because 0 have no positive 0, negative 0. And you solve for x, que es negative. And the famous point that we are looking for is minus a, 0. I suppose that my graph look like that. This is the x-axis. This is the y-axis. And y in itself was 0, 8. 1, 2, 3, 4, 5, 6, 7, and 8 here. 0, 8 represent the y in a set, and negative 8, 0, 1, 2, 3, 4, 5, 6, 7, and negative 8 here. Well, I anticipate the graph is something like that. It's the line in this direction is the same line in opposite direction. This is the graph of the f of x equal absolute value x plus a. I promise that we study in detail transformation next time, but now the most important is focusing in the function notation and the possibility to open function notation. Any questions so far? Okay, one classical question in the test, well, in the first test, is using one famous application of the function notation is called different quotients. Different quotient, guys, we are using in calculus. The student can need to take calculus. Different quotient, difference quotient. And what is the formula of the different quotient? Well, the formula is like that, using function notation. You have a function is given, and the formula for the different quotient is f x plus h. We are doing one translation minus the original divided by h. This is the formula for the different quotient. Different quotient. Let's do an example to understand this. And let's try to understand the interpretation of this. Okay. Suppose example one of the different quotient. Suppose f of x equal x squared minus 5x plus 6. This is given. The function is given. And the question say compute different quotient. Okay, using the formula. Apply function notation several times. Okay, I recommend do step by step. Step one is compute that part. And that part is just replace x for x plus h. Who is h? Well, h is arbitrary constant, que es the translation. Entonces is x plus h square minus 5 paréntesis x plus h plus 6. So the only thing I did was replace x for x plus h. I leave it like that? No, of course, no. You manipulate this. You apply FOIL here, FOIL, and multiplication x plus h times e cell is x squared plus xh plus xh again plus h squared. So I did that. X times x, x squared. X times h, xh. H times h, I put in the same order. And h times h is h squared. Now distribute here, minus 5x minus 5h plus 6. And leave it like that. Well, almost. I need to combine like term. So it's x squared plus 2xh, because it's the same, twice, plus h squared minus 5x minus 5h plus 6. We can combine this and this? No. Leave it like that. It's perfect. We did step one. Step two is doing everything in the numerator, in the formula for the different quotient. It's easy because the only thing you should do is subtraction f x plus h. Okay, we compute before in the step one and subtracting the original. Let's do it. Yes, I just copy x squared plus 2xh plus h squared minus 5x minus 5h plus 6 minus the original. Who is the original? This is the original. You see a subtraction, the polynomial, well, basically you put inside the parentheses, or directly you change the sign. This is minus x squared plus 5x minus 6. So because it's minus, no? And this minus change the sign of this second part. Look what happened. What happened? The happened is, okay, this guy cancel out. Wow, like that. This guy cancel out, this guy cancel out, and stay alive only. Stay alive only 2xh plus h squared minus 5h, and that's it. In step 3, the only thing you should do is the last part is, according to the formula, divided by h. Look here, divided by h. So basically I copy 2xh plus h squared minus 5h divided by h. And this is super easy because it's polynomial divided by a monomial. And you can separate one by one like that. y es obvio que this h is cancelled. This h is cancelled, but only one. And this is cancelled completely. Entonces, what is my famous final answer? My famous final answer is different quotient is equal to x plus 1h minus 5. Boom. Final answer. Do you follow me? Too long? Sorry. Different quotient. Okay, what is the interpretation different quotient? And calculus, when you take calculus, no? The interpretation. Do you follow me in the algebra? Any question, guy? Do you follow me? Totally lost? Do you understand or no? Come on. Opinion.
Yeah, I understand.
Oh, I understand. Everyone understand? No problem?
Yes.
I promise.
Yes.
In the review package, we go over again to the another example, right? Try to interpretation this different quotient. What is that? What represent that? Suppose we have a graph of the function. This is y. This is y. This is y. Suppose we have a graph of the function. And we select 2 points on the graph. This point and this point. And this point I call x. Yeah, that point I call x plus h. Because that distance I suppose is h. Now I know okay, this is f of x, que es y. I know que this is f of x plus h. Entonces, according to the definition of the different quotient is f of x plus h minus f of x. Okay, by the way, is that distance. Let me show you. The blue distance is this part. Divided by h. And h is that distance. So what is the interpretation? What is the reason? Que es this ratio. It's like a wrong and right. You know, wrong and right. I suppose you remember the slope definition. It's a slope of the secant line. So we have a line. Look, let me show you. We have a line. Okay, connecting this point. Okay, connecting this point. You are doing hypothetical line. Actually, a secant line because crossing 2 points. Entonces, what is the meaning of the different quotient? Well, the meaning is this is the slope of secant line. Secant line. Okay, connecting 2 points, two arbitrary points, point 1, P1, and P2. And this is important in calculus because in calculus you need to understand if the function is increasing, decreasing, if it goes up, goes down. So this is important, okay? Do you need another example of the different quotient or no?
I have a
Go ahead.
Is the secant line so I put 2 points?
I don't understand anything. I hear quack. Come on, speak slowly.
Hello.
Come on.
If the secant line connects 2 points, like
Yeah.
on purpose.
Tangent line is 1 point. Secant line is 2 points. Okay, secant by definition you have a curve, you have a line crossing 2 points. This is secant, and tangent is 1 point. Tangent line, secant line, geometry. Good.
Yes, thank you.
Pleasure. I have a question. Do you need the another example? of the different quotient or no? No. It's okay. You understand very well. And the review, I promise we go over again to this, right?
Yes.
Okay. So no more example. It's okay. It's enough.
Yeah, it's good. It's good.
Okay, it's good. Excellent. Okay, guys. So now, I want to illustrate how we determine domain and range. This is the most important part. Domain and range of the one function using the graph. Using the graph. Using the graph. Suppose I want to complicate your life, I put it the weird graph. Weird graph que we have some gap, some hole. This is my x-axis. At 90 degrees, we have the y-axis. And the graph I propose investigate. Okay, this is y. This is x. That's weird. Look like that. Look, let me show you. Whoa. We're using another color. Red color. Okay, suppose here. Okay, wait a second. This is 0. This is 1, 2, 3, 4, and that's it. Okay, entonces look like that. And 2, we have a hole. And the hole you indicate like a circle open. And 2. And 3, we have another circle, but it's closed. And between 3 and 4, we have a gap. In 4, we have another circle open. And that's it. And that's it. That value is, 4. Maybe. This value 5. Okay, and the y value. So now the problem is determine domain and range. Look in the graph, no mathematics. Look in the graph. This is a classical question on the test. And remember, domain is the set. Domain by definition is a set of x value in which the function is defined. Is defined. Si it's undefined, is out the domain. And the typical undefined is a hole. So we have here a hole. Look, a hole. And how do you know it's a hole? Because it's the circle open. And this is no. This is a circle closed. And this is a circle open again. When it's open, it's undefined. Open, undefined. Circle, full, defined. Okay? Entonces, how do you find domain? Well, domain is easy. You take several points on the curve. Bam, 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 bam. Bam, 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 bam. And you project it onto the x-axis. Projection. It's obvious that this is coming from negative infinity. Good. And stop in 2. Why stop in 2? Because in 2 is undefined. We have a hole here, right? And we continue from 3, no problema. In 3, yes, include 3. And the symbolic way to indicate that is bracket, because it's defined here. And between 3 and 4, we have a gap. We have no functions. Therefore, no domain. Now we continue that part to infinity positive. And here 4, no. It's a whole, entonces es undefined also. Entonces, how you write that? Well, you write like that. Domain of this function is from negative infinity, so from left to right, comma to parentheses, because 2 don't, is completely out the domain, union, parenthesis 2, 3 bracket, because 3, yes, is inside the domain, union, 4, no, it's a whole also, 4, infinity. Super good. What about range? Range is the set of the y value. So at the same point that you have here on the curve, now you're projecting onto the y-axis. So I suppose that when you project it onto the y-axis, let me change the color. You go from negative infinity here, negative infinity, to 4, no? Pero no incluye 4. 4, no. 4 is out of the game because it's undefined. Here is undefined. Undefined. Entonces, paréntesis, no bracket. And continue from 4 to 5. In this small interval. Okay, entonces my range is from negative infinity, comma 4, parenthesis, no bracket, no include 4, because I can see we have hole here and hole here. It's a coincidence. Union 4,5. And include 5, yeah, include 5, because in 5 we have close. Include 5 bracket. And we have the rest of the range greater than 5. No, because we have no graph. So never that function in red color touch 6, 7, 8, and so on. Okay, this is a classical example of determined domain and range. Look at the graph. Of course, I very complicated this using whole and using gap. The majority of the graph have no. Suppose another more easier graphic, for example. Suppose this graph. Que suppose que es de parábola, ¿no? Like that. Suppose easy. No hole, no gap. It's a parabola like that. And this point is the most important point, is the vertex, is a point 3, 1. Entonces, I ask you, determine graphically, look at the graph, where the domain and where the range. You see, one professor, I don't see any gap, I don't see any hole, therefore the domain is all real number, from negative infinity to positive infinity. Another way to see this, you projecting any point on the parabola onto the x-axis, and you see that the domain is all real number. So it's, look, from negative infinity to positive infinity, the projection. This is positive infinity, and it's a negative infinity. Okay, suppose you're projecting this. Oh, okay, it's this. But this continues forever. Okay, this continues forever. This continues forever. Now, the range, no. Why no? Because we have parabola only from 1 to infinity positive, that part. So my parabola is extending from 1, including 1, of course, to infinity positive. And no infinity negative, we have no parabola. So my range is determined from the set present in interval notation, no? Is a bracket 1, positive infinity. Good? Complicated or easy? Well, the complicated part, go ahead. Question. Go ahead.
Oh no, I said good.
Okay, you said good. The little bit complicated part is when you have not the graph, you have the equation. Yes, I asked you domain, and range is extremely complicated. So never I ask you about the range when you have equation. Now, determine domain using the equation. Now, it's the next topic. Next topic is determine domain. Determine domain. Domain using the equation, that equation. So in this case, the equation is given. And you need to do something in order to determine the domain. Okay? Next idea. But let me explain. The supposition, you assume when you have equation that the domain is all real number, except restrictions. And we have restriction in three cases, 1, 2, 3. When it's undefined. It's undefined, guys, when, for example, my function contains division to things, p divided by q. P is an expression, q is another expression. I know that q never would be 0 because it's 0 is division by 0, and you know that any number of function division by 0 is undefined. To avoid that situation, you investigate the denominator part, and the denominator part never is 0. Si it's 0 undefined, it's completely out of the domain. Another restriction, potential restriction, is when you have a square root, any expression. So you investigate the expression inside the square root, you remove the square root, and this expression must be non-negative, because I know what happens when it's negative. It's imaginary, FII, and FII is completely out the hypothetical domain that I suppose at the beginning is all real number. And number 3 is a combination 1 and 2 together. Okay, is, for example, P divided by radical E. Well, in this case, you have radical, no allow negative inside, and no 0 because it's division by 0, because the square root 0 is 0, no? Square root 0 is 0, and when you divide something divided by 0, it's undefined. So to avoid that situation, you take the expression inside the square root, and it's only positive, no 0. Entonces, these are the 3 restrictions, the 3 most important restrictions. I promise again, next chapter, for the second test, we study another restriction, but so far, this is the most important restriction, and you apply this idea in the example. Okay, I want to show you now. Okay? Let's see example. Here. Example 1. Example 1 say, determine the domain of this function. F of x is equal x plus 4 divided by x squared minus 2x plus 3. And remember, my goal is to determine only domain. Range, no, range is more complicated. The question is always domain. So in this case, I saw one of the supposition is all real number except restrictions. And it's obvious that we have restriction because you are doing division. And you take the expression in the bottom, que es x squared minus 2x plus 3, and you enforce it to be non-zero. Now, how you solve this inequality? Well, I have no idea. However, I convert to equation because for me it's easier solving the quadratic equation. But I know, okay, this statement is a negation of this statement. So the bad guy in the original, the bad guy in this, is the good guy in this. It's a negation. But it's okay. It's okay. I convert two equation because it's easy for me. Yeah, I solve this equation. I suppose that by factorization is pretty easy. It's 3 and 1. 3 times 1 is 3, and 3 minus 1 is 2, and the sign is negative and positive. You separate into linear equation, and the first solution is positive 3, and the second solution is negative 1. Actually, this is the solution for the quadratic equation, but don't forget that the problem that we're solving is not equal. Entonces, it's not equal. This is the bad guy. Entonces, what is the domain? Well, the domain is all real number except the bad guy. Who is the bad guy? 3 and negative 1. Okay? However, in the test, I asked you express the answer in interval notation. And maybe it looks like a little bit complicated, no? But no. Let me try. This is my all real number line. Here, horizontal. All real number line. Okay, this is infinity, positive. This is infinity, negative, 0 in the middle. 3 is 1, 2, 3, and negative 1 is here. So what's going on? The domain is all real number except this guy, que is 3 and negative 1. That means, in other words, in the number line, we have two holes. One hole here and one hole here. And the rest is okay. This is okay. This is okay. And this is okay. Okay, this is one graphic representation of the problem, no? However, I want the answer not like that. No. This is correct, but no, I don't want this. I want in this way. Look, it's from negative infinity, comma negative 1, parenthesis, que es this interval, union, negative 1, comma 3, que es this interval, union, 3, comma infinity, que es this interval. Final answer. Any question? Do you follow me? Everyone understand very well example 1 or no? Question, please. Come on. Stop. Everyone follow me. Wow. This is super smart class, or this is super easy topic, no? No opinion. I don't hear anything. No? No opinion?
No.
It's okay? It's okay, sure? 100%? I bring a lot of examples. Now, we spend the rest of the time doing example, domain. Example 2 for the domain. Example 2 for the domain. One function, one equation of the function is given, and you determine the domain algebraically. Suppose g of x is equal radical 3 minus 2x. My question is, we have restriction, yes or no? Let me copy the idea for the restriction again. This is important.
Yes,
yes. What kind of restriction? Number 1, number 2, or number 3? Number 1 is P divided by Q.
Number 2.
Number 2, you are right. Radical E non-negative, and P divided by radical E, semicolon, E positive. Number 2. He said that we have restriction like that. Entonces, si es restriction like that, you take then the expression inside the radical, you remove mentally the radical, and you enforce it to be greater than or equal to 0. And you solve this inequality and end the story. Let's do it. Minus 2x is greater than or equal minus 3. I move 3 to the right hand side like a negative, and finally divide by negative to both sides. And you remember, you have to remember, when you divide by a negative number, the inequality sign is reversed like that. So x is 3/2. 3/2 is 1.5. Is 1.5. Let me represent this domain and the number line. Okay, it's infinity positive, this is infinity negative, this is 0, 1, 2, 1.5 is in between 1 and 2 here. And this is a less than or equal. Less than or equal to the left. And include 1.5. Of course include, because I saw here equal sign. And the symbolic way to indicate this idea is bracket. In 1.5. Therefore, the domain of this function is equal from negative infinity, comma, 1.5 or 3/2, either way. Bracket. Any question, right? Super easy. Super easy. No question, right? Okay. Let's move on to example 3. I have a lot of examples. This is important for me. Important. Example 3. Suppose h of x is equal 4 divided by square root x minus 9. Okay, I copy again the restriction because I cannot, or I don't want, forget. Restriction 1, restriction 2, restriction 3.
Restriction 3.
Restriction 3, you are right, mister. Restriction 3. Radical E non-negative is positive or 0. And restriction 3 is said is when it's positive. So how you set up? Well, you take the expression inside the radical because it's the radical in the bottom, no radical in the top. Radical in the top is more flexible, allows 0. But radical in the bottom, no, because division by 0 is undefined. So you take the expression and you enforce it to be greater than 0, like that. So with this elementary inequality, greater than 9. Let's do in the sketch of the domain. Or real number again. Infinity positive, infinity negative, 0 here, 9 I suppose get here. This is greater than 9. Greater than 9 is this interval. Include 9? No. Why no? Because I don't see any equal sign here. No. Entonces es paréntesis. And the domain of the function h is equal paréntesis 9 comma infinity positive. Super good. Super good. Okay.
I have a question.
Go ahead.
What do we for?
Hey, I don't understand. You put the microphone a little bit loudy or ESP? Say again?
The 4.
The what?
The number 4.
Number 4. What is number 4?
On top of the radical.
You see the previous example.
Yeah. No. 1/4 divided by x minus 9 square root.
But I don't understand. This example you have in your mind, or I put in the board?
No, it's the one that you have on the board.
Which one? Number 3?
No, yeah, I just want to know like why you got rid of the 4.
Good. I understand your question now. Good question. Okay, do you see And the restriction, I don't care. I don't care P. P is totally irrelevant, no important. So you mentally delete this 4. This do not participate in the game. This 4 do not participate in the game. It's clear for you?
Yeah. Yeah.
Wow, too noise. What is the reason that it had too noise? Okay, your internet connection is good or not? Oh, let me see. Okay. Do you hear me well to me, no? When they speak, you understand, no? Or no?
Yeah.
Isabella?
Yeah, I can hear you.
Oh, nice. Nice. Okay. Try to fix the microphone, guy. Oh, using the chat, maybe. Okay, let's continue. Example, domain. Okay, I want to complicate a little bit. No, not too much. Okay, look, example 4. It's very, very interesting. It's weird, but interesting. Look, example 4. Suppose the function, the name is P of x is equal x over x squared plus 1. Investigate domain. Well. I know que the supposition the professor explained is all real number except the restriction. And restriction, we have 3 kinds of restriction. 1, 2, 3. Restriction 1 is P divided by Q. Q non-zero. I don't care P. P do not participate. So P, this element is completely irrelevant. Radical E is greater than or equal to 0, and P divided by radical E, this guy not important, E positive. What do you consider you apply in this case? The restriction 1, 2, or 3?
Number 1.
Number 1, it's obvious. You take x squared plus 1 equal no 0. It's totally illegal. I avoid 0 in the denominator, but it's a quadratic equation. Entonces, in my opinion, I solve the equation much better than inequality. No good inequality. This symbol I don't like. I don't know very well manipulate. Well, I know actually because it's equal, and finally I change to no equal, no? Entonces you solve for x here. This is a quadratic equation. Entonces you apply the square root method. You move 1 to the right hand side like a minus. You apply square root both sides. Entonces x es equal plus or minus. I know que this is imaginary que es I, ¿no? Entonces the thing I try to looking for is the domain. Este restriction. Pero the restriction I discover que es imaginary. Imaginary like completely out the all real number, no? It's in another dimension. So the restriction is living in another dimension, no in the famous all real number that frequently we are using. So in this line, it's all real number. However, the imaginary number, not here. It's in another place. So what is the domain, in your opinion? In this particular example? No idea?
No idea.
No. Okay. I try to repeat again the idea. Look, the supposition you assume okay, the domain is all real number except restriction. But the restriction okay, we investigate in this specific example is imaginary. That means that we have no restriction in the real field. Therefore, I repeat the question again. What is the domain of this function?
Negative infinity.
To interval. I need interval. From negative infinity to
Positive infinity.
excellent. All real number. This is the domain. Okay? Because the restriction living in another dimension, the restriction living in Jupiter planet. Okay, it's not the Earth planet. Okay? No real field. It's imaginary. Therefore, we have no. O sea, es classical en algebra. When something is complex or imaginary, it's because do not exist. So this is equivalent to say, somehow, do not exist. Restriction. Therefore, we have no restriction. Therefore, the domain is all real number. Super good. I put this to example because it's important, no? To see at least one time. Let me complicate a little bit more. Entonces we have several combinations. So far, we studied an elementary example in which you have one restriction, get 1, 2, or 3. But sometimes you have more than one restriction. Suppose the example number, what number is? Number 5, no? Example 5, no? Example 5. In example 5, we have a function, f of x, is square root x plus 4 plus square root x minus 5. Wow. So we have, how many restrictions we have? How many? How many? And what restriction we using? Number 1, number 2, number 3? Huh?
Number 2.
Number 2. 2 times, right? Number 2, 2 times. So you take this expression and you set out like that. X plus 4, no negative. And you take this expression and you set out x minus 5, also non-negative. And you have in that moment a compound inequality and you connecting by and. How do you know that we connecting by and? Because you need to satisfy this condition and this condition. Because si one condition fails, suppose that this guy is undefined. And this guy no, is defined. So actually the total expression is undefined. So you need to guarantee that both expressions, both are defined, not undefined. Okay, do you understand the idea for the compound inequality? And how you solve the compound inequality? Easy. Easy, you solve them one by one separately. Look at that. X plus 4 greater than or equal to 0. I copy again. Solve for x greater than or equal to minus 4. And leave it like that for a moment, temporary. And let's do it in the second. The second is x minus 5 greater than or equal to 0. X greater than or equal to 5. Okay, and put together using and. How do you doing that? Well, okay, you are doing the number line, the famous number line here. This is infinity positive, infinity negative, 0 in the middle, 5 here, 1, 2, 3, 4, 5. And negative 4 is negative 1, 2, 3, and negative 4. That part is greater than negative 4. That part is this part. Okay, this continue forever, including negative 4. I did a graph only of this part. However, that part is from 5 to infinity in that direction. But let me using another way to highlight this. Not exactly on, here to see more clear. Let's continue forever, include final, because I know the equal sign include the point. So my question is, now this is a crucial moment. And is common element. And is common element, yeah, element, or is, in other words, is when the both interval, the blue and the green interval overlap or touch, common, share the same element. What do you think? What do you think? What do you think? What is the answer? The answer is the green, the blue, or together, or I don't know. I need to make a decision. Now this is a crucial moment to put together. Say again?
Together?
Together. Mm-mm-mm. No, no, no. No, no, no. Okay, okay. Suppose in two circles. This is the AB. And where is A intersection B? Intersection B. It's the common element. It's the common element. It's that part. Yes or no?
Yes.
So now we're doing exactly the same now, pero in the interval. It's easier because it's the one dimension. It's on the one line. What is the part que both interval, green and blue, share?
The 5 positive.
Exactly, exactly. In other words, the blue part is common, right?
Yes.
Now the final answer is, domain is bracket phi, comma infinity. This is domain of f of x equal this. Let me explain more clear. Let me explain more clear. Let me explain more clear. Okay, look. Let me show you. Suppose one hypothetic. Suppose one hypothetic. I pick here one value, 6. Okay, suppose que belong to the domain, right? I'm plugging in f and 6. Look, it's the square root 6 plus 4 plus the square root 6 minus 5. Well, 6 plus 4 is 10. And the square root 10 is a real number. It's obvious it's irrational, but it's a real number. And 6 minus 5 is 1, and square root 1 is 1. This is perfect, good. This give me one definite value, therefore belong to the domain. However, let me select one guy here, suppose 1. Okay, my opinion is completely out of the domain according to this idea. So you evaluate 1, and let's see what happens. You evaluate 1, f evaluate 1 is square root 1 plus 4 plus square root 1 minus 5. Well, this is square root 5 because 1 plus 4 is 5, but this is 1 minus 5 negative 4, and negative 4 is imaginary. This is radical 5 plus 2i. Completely out the line, the famous line of the all real number. This is undefined. It's in another planet. Okay, to say it's undefined. And so you select 1 here, it's obvious that both square root undefined. Makes sense, guy? Confusing or no? Question. Come on. This is the moment to ask me any question. Okay, your question is important for me. Minimum question. The student can ask me, Professor, what about that 4? That 4 do not participate in the game. Clear? One more example?
Yes. One more, please.
Go ahead. One more example. Is, suppose example 6, no? 6. Okay, this is important, guy. Is determine the domain when you have equation. Suppose g of x equal. Says in the top we have a square root. Okay, it's 2x plus 1. In the bottom we have x minus 4. Determine the domain. I asked for you how many restrictions we expect. How many restrictions? Let me recall restriction. Restriction is 1, 2, 3. 1, 2, 3. The restriction 1 is p divided by q, and q non-zero. Restriction 2 is radical e, and e non-negative. And restriction p divided by radical e, and e positive. How many restrictions and what kind of restriction you apply? 1, 2, 3. How many? How many restrictions? Go ahead.
One restriction, number 3.
Number 3, no, because number 3 is when you have a square root and the bottom. We have a square root here.
Number 2.
Number 2, yes, I agree. Because it's when you have a square root in the top. And that's it, number 2. Only one?
Number 1.
Number 1, only one, right? And number 1 restriction also, you say? Okay. You apply this, yes or no?
Yes.
And you apply this, yes or no?
Yes. So it's 2 restrictions.
It's 2 restrictions. 1 restriction of the square root at the top is 2x plus 1 greater than or equal to 0, and another restriction in the bottom is x minus 4, no 0. Okay, this is clear? This is clear?
Yes.
Let's do it. Now, I manipulate separately each inequality. I split the paper into 2 parts. I focus it in that part. It's easy. It's 2x plus 1 greater than or equal to 0. So for x, 2x greater than or equal to negative 1 divided by 2. X is greater than or equal to negative 1/2. Stop here. This is one piece of information. Another piece of information is x no 4. Ooh, that means in 4 we have a whole. Okay, but I try to understand geometrically this idea. This is my famous real number line again. Okay, infinity positive, infinity negative, 0 in the middle, 1, 2, 3, and 4. And negative 1/2, I suppose this is negative 1 is in between 0 and negative 1. This is negative 1/2. Negative 1/2. This interval is from negative 1/2 to infinity. To the right, no? Because it's greater than. However, when you get 4, you found the whole here. Because 4 is totally illegal. Because when you evaluate 4 minus 4 is 0, division by 0 undefined. Therefore, my domain, or the domain of G, is that piece, okay, by the way, including negative 1/2, because I saw here equal sign, bracket. It says bracket, negative 1/2, comma 4, because it's this piece. And 4, well, maybe we have parentheses because it's undefined, a whole. And continue for the another interval case, interval from 4, not including 4, of course, to infinity. Just that piece. Super good or no? You get the idea? You get the idea or no?
Yes.
Well, I bring up one more, and that's it. And that's it of that part, because I want to start another topic. We have time. I mean, we have class to take technically to 11:10. However, I want to finish in 11 because in 11:15 I have another class, so I need time to prepare for the next class. Okay, one more example of the domain when the equation is given. And you help me, guys. Example 7 is a little bit complicated because we have several restrictions. Suppose the function p is the name of the function. And this is the square root 2x plus 3 divided by square root x minus 4 minus 8. You need to investigate the domain of this function. I recall that the assumption is the domain is all real number except the restriction 1, 2, 3. Restriction 1 is P divided by Q. Q no 0. Restriction 2 is radical E.
So you have restriction 2 and 2.
Restriction 2 and 3. And 1 no. And 1 no. I don't know.
Yes.
Yes. Oh, yeah. Okay, we have, look, we have radical in the numerator, que actually is restriction 2. Radical in the numerator. So we're using that. Boom. In this radical. So you copy here. 2x plus 3. I need to guarantee that it's non-negative. This is okay. I did that part. Okay. Entonces you say also que restriction 3, no? Because I saw radical in the denominator. Yes or no? Yes or no?
Yes.
Yeah, of course. Entonces the expression is x minus 4 must be positive. And what about this restriction? We using this or no? Q. Oh yes, because I need to guarantee somehow that the expression in the bottom never is 0. Entonces you copy square root x minus 4 minus 8 never 0. Make sense or no? And after we manipulate. What is the conjunction connecting this statement? I know. Because you need to guarantee this and this and this to be inside the domain. And you solve it one by one. This is easy. This is 2x plus 3 greater than or equal to 0. 2x greater than or equal to minus 3 divided by 2. No problem. Greater than or equal to minus 3 over 2. Okay, by the way, this is negative 1.5. I put in decimal because I visualize much better in the number line. Okay, so this is the first restriction. The first restriction. Let me using blue color. Okay, the second one is easy. It's x greater than 4, no? And that's it. Let me using another color. Green, maybe. And the second one look like equation, no? Remember, I changed to equation because for me it's easier. I am strong solving equation. I am not strong solving this kind of inequality. But you know it's the negation of this statement. Does it look like radical equation? You isolate the radical. Isolate the radical, square both sides. Exactly, we explained last class. X minus 4 because the square root and square power cancel out each other, and this is 64. 8 to the second power, no? 8 times 8 is 64. X is 64 plus 4 is 68. Actually, it's not 68. Not 68. Remember, this is a negation, 68. And this is a restriction number 3. Number 3. Let me highlight in another color, maybe yellow. Okay. I solving 3 inequality. I detecting 3 restriction. I set out the restriction. I solving 1 inequality by 1. Now this is a crucial moment in which you put together in the number line. Okay, put together. Okay, infinity positive, infinity negative. 0 in the middle. Okay. 4, 1, 2, 3, 4. 68 is too far. Suppose 68 too far. This is infinity and this is 68. Okay, and negative 1.5 is negative 1, negative 2 is in the middle between negative 1.5. Let's do it. Let's do it first, the blue part. The blue part is from 1.5 to infinity, because it's to the right, it's greater than. Continue forever. Good, and include 1.5, because I saw here equals sign. 4, green color, es greater than 4. Entonces es from 4, no include 4, to infinity again. But wait a second. Let's do it no like that. Let's do it no overlap. So put here to visualize more clear. This is infinity, and no include 4, because I don't see equal sign here. And 64 is a hole. 64 is a hole. It's a yellow hole. Yellow hole. Okay. Now help me. What is the domain of P? P of X.
Is it 4?
Paréntesis 4, comma, to infinity.
Yeah.
No, because we have a hole in 68.
So it's 68.
Pero entonces 69, 70, 71 no don't belong to the domain.
I don't know.
You don't know? Why not? You have only one hole, but this continuation, continue in this direction. 68 is a hole. You skip the hole, and you continue from 68 to infinity. Wow, amazing. 4 to 68, no include 4, no include 68, and now 68.1, yes, belong to the domain, no problem. The only guy gets the bad guy is 68, but 68.1, no, it's good, belong to the domain. Good or not good?
Good.
Excellent. Any question, guy? Entonces es easy or relatively easy, no? Detecting the restriction, you set out the compound inequality, and the rest you solve it. Go ahead. Question.
So why isn't negative 1.5 part of the domain?
Because remember, you need to satisfy any condition, the blue condition, green condition, and yellow condition. Entonces, what is the part que es intersection? What the part que green and blue share? Es obvio. What is the problem? Suppose to explain clear this idea. Suppose this piece, this number, 3, 2, 1, 0, negative 1. This is bad, because when you plug in this number, suppose 0, you plug it in here. 0 minus 4 is negative 4, and the square root of negative 4 is 2i. Imaginary, not good.
Okay.
Okay? Pleasure. Okay, so now I want to present in the rest of the time that we have new idea, que es piecewise functions. Piecewise. So not always in the real life, we need to model something. We can represent the function like only one equation. No. Sometimes it's more complicated. So for example, you have a piecewise functions. It's a function que, for example, have different pieces, and different pieces you need to evaluate in different conditions. So what is the symbolic way to indicate piecewise function? Symbolic way. You put a big curly bracket, and you copy, for example, x is one expression. It's valid if x is in between -4, and 0. Another piece is 1, que es a constant function, if x is just 0, equal to 0. And 3x if x is greater than 0. Let me try to interpret this idea. What mean that? Well, you have the famous real line again. Okay. Infinity positive, infinity negative. 0 here. But unfortunately, our domain starts in -4. -1, -2, -3, -4 here. Because I do not define in my piecewise function any value for -5, -6. So my domain, so this part corresponded with this expression. So this interval corresponded with this expression. So now the y value, because this is y, of the function is equal x, y equal x, here in this piece, piecewise. Specifically, n0 is 1 point, is 1. Here, n0, y is equal 1. And after 0, positive numbers, is that part, the expression is different, is y equal 3x. Okay, this is the interpretation of this. Now, what is the typical question in the test? Well, there are two questions. But let me try to cover today only the first question. Suppose que you evaluate in different values. Evaluate in 0, evaluate in 1, evaluate in -1, evaluate in 40, evaluate in -2, enough. So what is the process? The process is you see what is the value that you need to evaluate. For example, let me select orange color. You plug you in your mind care this value 0. So 0 belong to the what interval? 0, where is 0? Oh, 0 here. And our piecewise function 0 here. Entonces now is y value is 1. That's it. In this case was easy. 1, no. 1 belong to this interval because it's positive number. Look, the yellow part. This is 1. X equal 1. And x equal 1, well, use substitution and the expression 3x. So, okay, listen to me. The process is you take the element in the domain, que es 1. Using this element, you select, because you will have 3 possibilities. Inside the piecewise function, what is the expression que represent this? ¿Qué es this? For 1. Because 1 is greater than 0, no? Satisfy this condition. And you plugging in x equal 1. This is one symbolic way. Plugging in, say 3 times 1 is 3. Do you follow me? Okay, step number 1. Take the element in the domain, que es 1. Now you go here. Selection. What is the interval below 1? The third one. Because 1 is greater than 0. You select this piece. 3x. I'm plugging in 1. Let's do it -1. -1 now. -1. -1. I suppose it belong to this interval. The green one. Because -1 is here. Look. -1. Belong to this. Therefore, what is the expression? The expression is this expression. Que es x. And evaluate at x equal -1. X equal -1. Well, it's obvious. it's obvious plugging in is -1 because it's -1. -1 replacing, x for -1. It's obvious, right? And what about 40? Well, 40 is obvious que belong to this interval because 40 is greater than 0, no? 40 is greater than 0. I'm plugging in 40. Entonces, the expression is 3x at x equals 40. Es 3 times 40 is 120. Boom. Este answer que hay 1, guys. 1, 3, -1, 120. And -2, bueno, -2, -2, -2, -2 belong to this interval, to the green one, because -2 is here. Look, -2 is here. Entonces, I select the expression x, que es the expression que belong to this interval. Entonces, x such that x is -2, and evaluate is -2. You get the idea? No, complicated, right? Hey, question. Do you follow me or you are tired? Are you tired? Too much, eh?
I follow.
Okay, now, one more, that's it. I promise, guys. Relax. Everything's gonna be okay. Suppose another example. Piecewise function. Suppose another. No too complicated. It's easier. Look. Okay, suppose this. Suppose f of x equal x squared. So it's a piecewise function, the symbolic way using the curly bracket. Then you have different pieces. And different pieces obey to different conditions. If x is in between -2 and 2. And this is if x is greater than 2. And suppose que you need to evaluate en -2, you evaluate en 2, you evaluate en 1, you evaluate en 3, you evaluate en 4, and you evaluate en 0. Entonces the process is clear. You take this number, boom, and you investigate at what interval belong. It's obvious que belong to this interval, yes or no? Now the expression que is select is x squared. I'm plugging in x equal -2. Entonces -2 squared, que 4. Do you see? Now 2 positive. Again, belong to this. Same thing. Entonces, x squared, you select, you take this expression because this is matching with this interval such that x equal to positive. The answer is the same, 2 squared is 4. Okay, 1 here, and 1 again belong to this interval because this interval is in between -2 and +2, including -2, -1, 0, +1, and 2, and of course the decimal in the middle. So you select again the expression is x squared, evaluate at 1. And 1 squared is 1. Answer 1, answer 2, answer 3. And 3, and 3 is different. In 3, these 3 belong to this interval. Therefore, the selection is this expression. Is 2x minus 1 such that x is 3. Plugging in 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. Okay. 4. 4, exactly the same. Belong to this interval. And you evaluate. Entonces, it's easy. It's 2 minus x. First of all, identification and what interval belong our specific number that I want to plug it in. After this allow me selection the expression. And I'm finally plugging in x equals 4. 2 times 4 minus 1. 8 minus 1, 7. Boom. 0, 0, 0, 0 belong to this interval. Okay, now 0. So I select this expression. Is x squared. Add x0. 0 squared is 0. Boom. Final answer. Do you get the idea?
Yes.
Piecewise function. Okay. I want to complicate more. No, today, of course. Because next time we are doing the graphic of the piecewise function, right? Okay, guys. Thank you so much for your attention. I know that this class is hard because it's intensive.